Welcome to Unit 1.3. Today we're going to talk about how do I identify the domain and range of a given function, and how do I combine functions by composition. So, a really quick review on the operations of functions. Given that f of x is equal to negative 4x and g of x is equal to 2x plus 4, I want to do these operations. We talked about addition and multiplication. Subtraction, division is very similar. So we want to find the addition, and I want to call it, when I add f of x and g of x, I'm going to call it h of x. So h of x is equal to f of x, which is negative 4x, plus 2x plus 4. Combining like terms, these are my like terms right here. Negative 4x plus 2x is negative 2x plus 4. So h of x is equal to negative 2x plus 4. Now let's look at subtraction. For subtraction now, let's just change this color so it's better. H of x is equal to f of x. Again, this is negative 4x. Take away, and I'm going to put this in parentheses because there are more than one terms. Now, equals. Remember, very careful, this is where we make the mistake. So negative 4x. Remember there's that invisible 1 right here. So we have to distribute this, we have to distribute this invisible 1 that's normally right here. We have to take that and distribute that over. So when I distribute, this becomes minus 2x minus 4. Now that you have that, we can go ahead and combine. So our final answer will be h of x is equal to negative 4x minus 2x will be negative 6x minus 4. And this will be my final answer. Let's go into a multiplication. So h of x again is equal to f of x, which is minus 4x, times, and I put it in parentheses because I have more than one terms. So remember, we have to distribute to both of these. Don't forget that. This becomes h of x is equal to minus 8x squared. So negative 4 times 2 is negative 8. X times x is x squared. Negative times a positive is a negative, so I know this will be minus. 4 times 4 is 16, and then we have our x. This becomes our final answer. And then the last one that we have is division. Very similar to our multiplication, same process. H of x is equal to f of x, which is negative 4x, divided by g of x, which is 2x plus 4. And that's all I do. This is all I need to do. This is my final answer. So that's a quick review on addition, subtraction, multiplication, and division. So let's look at finding domain. Fill in your blanks as we go along. So finding domain. The domain, as we referred to in an earlier lesson, is the set of all inputs. It's all possible x value or x coordinates. So when you think of the word domain, you need to think of x values. X, all my x. Now, the range is a set of all outputs. So range, output, which has to do with all my y value. So most of the time we see f of x is equal to some kind of function. Remember, the x is my domain, and the f of x, which is my y, same thing as my y. F of x is the same thing as me having y. That's my range. So you will see this diagram below. So what I want you to do is take notes, pause the video if you need to. I just want to go over a few things. So notice here, and let's just get our highlighter in. Here I see an open circle. So remember, open circle because I'm using less than or greater than. I see a parentheses. Most of you asked me about this already. What does that parentheses mean? That parentheses mean that that number is not included, whereas this here is known as a bracket. That means that the number is included. Many of you had asked me about this, so please make a note. And notice that here I have a closed circle, which we talked about already, is closed because we have a less than or equal to or a greater than or equal to. Then this little sign right here, most of you remember this or should remember this from algebra. This means union. It's putting together everything. And then one new symbol that I don't think you've noticed or seen before is this line right here. That line, all it means is such that. So if I was to go read this, I'll say x such that negative a is less than x and x is less than a, which is basically right here. So those are some key terms and expressions and that we need to know. Take a note, make sure you pause this, draw your arrows so you have these in hand. Now let's see. Identify the domain and range from a graph. So this is my graph. Remember, domain has to do with my x and range has to do with my y. So domain is everything on my x-axis. Notice it's here at -2 and 4. Notice the circle, and it's a closed circle, meaning that the number is included. So I want to write a notation for this. So when I'm writing my notation, it will be something like this. The domain D is equal to x such that -2 is less than or equal to x and x is less than or equal to 4. Remember, I use less than or equal to because these numbers are included. Now, what about my range? Remember, range is y value, so I need to see the highest y value. In this case, it is 3 and -1. So I know my range is going to be somewhere between there. So when I'm writing these notation, I'm going to do y such that -1, remember my lowest, is less than or equal to y, which is less than or equal to 3. Again, I'm using less than or equal to because it goes back to my included circle. How about this example right here? I have a graph that looks something like this, and I want to find the domain, and I want to find the range. So the domain, again, it's all your x values. Notice these arrows. What does that arrow mean? Remember, when you put arrows on a graph, it means it goes on for ever and ever and ever. So the domain for this is going to be, so since this is going on forever and ever and ever, I'm going to have open parentheses, and when it goes down, that's negative infinity. Remember, domain x, I'm going to be going down all the way. I don't know where I'm stopping, comma, positive infinity, because I don't know on the positive side where I'm stopping. Now, for the range, what am I going to do? The range, y value, what's the highest possible y value? Here, right here, perfect, that's a 4. Now what about this? Remember, the arrows goes down and down and down and down and down and down. So for my range, it's going to be at negative infinity because it's all the way at the bottom, and it's going to be at 4. And notice it's going to be a bracket because there's 4 is included. Look at the dot right here. That's a point and it's included. It stops it there. Now what about a table? If I have a table and I say find a range and find the domain. Again, you have to remember domain is all your x values. That's my domain. And my range is all my y values. So if I was to write this as a domain and range, that's what I'm going to do. Domain x such that x is equal to all my values in the range is y such that y is equal to blank. So notice here I wrote it this way. In the previous example I wrote it in like a simple coordinate kind of pair. Here I have a notation. So these, remember, goes back to our diagram. I can do it in integral, a set builder, I can graph it, I can do it in standard notation. Or it doesn't matter which one you want to use, okay? So let's get into composition of function. What is a composition of function? Remember, composition is when I'm combining things. So applying one function to another. It's like if we have multiple function machine. You know, we have those function machine, you put x in and then f of x comes out. So the difference is that we know the order. We know the order that this is going. So the notation for a composition of function is f of g of x. You can see it as this way, or f with a little circle, g, close parentheses, and x. Either one of these, we read it as f of g of x. And we always do the one in red first. Always, always, always. So let's see how this works. So we have a few examples, but I want to make sure. So this is f of g of x, meaning I'm taking g of x and put it into f of x. So everywhere I see x, I'm going to replace it with g of x. So this becomes f of x is 2x minus 5, and g of x is negative x plus 2. So I'm going to take this and put it into there. So this becomes 2 parentheses negative x plus 2 minus 5. I will distribute. This becomes negative 2x plus 4 minus 5. Remember, I distribute over. Now, this combining like terms, I get minus 2x minus 1. So this is f of g of x. Now, number 2 says I want to find f of g of 2. So it's almost the same thing, but now I'm evaluating it for the number in parentheses. As you can see, we found that f of g of x in the previous example was 2x minus 1. So now I want to find f of g of 2. All that means wherever I see x, I'm going to put 2. If I was to work this out, negative 5. And that's the value. Okay? So f of g of x means I'm taking g, wherever I see that x, I am replacing it. Okay? Let's try some more. This one says find f of negative 5 and g of x. So f of negative 5, that's the first thing I need to find. What's f of negative 5? F of negative 5, let's use f, so 2 times negative 5 minus 5. This becomes negative 10 minus 5, and we add that. So this becomes g of negative 15. Remember, we're not finished. We do this first, then I'm going to do the next. So g of negative 15, remember it's negative 15 plus 2. Remember, it was negative x, so it's my x is actually negative 15, so you keep that in parentheses. This actually becomes 15 plus 2, so, and this, my final answer is 17. Be careful. The really tricky thing is you have to remember to do the parentheses first. So here, f of h of negative 4. All this means I do h of negative 4, so h of negative 4, this becomes negative 4 squared plus 3. Negative 4 squared is 16 plus 3 is 19. So now I kind of replace this with 19. I need to find f of 19. What's f of 19? So f of 19, remember I'm using this function. It becomes 2x minus 5. Oops, not x. We know what x is now. X is negative 9. X is positive 19. So 2 of 19. So if you were to do this, if you're not sure, check your calculator. 19 twos is 38 minus 5 is 33, and that's my final answer. Remember, pause the video, take a minute, let it sink in. Got 2 more examples to go. So, g of h of negative 1. So this means that I do g of h of negative 1. I do the first one. So h of negative 1. H is right here. Perfect. Negative 1 square plus 3. This becomes 1 plus 3, which is 4. Then I go ahead and do g of 4. I'm using this right here, so this becomes negative 4 plus 2. Final answer is negative 2. Perfect. One more example to go. Let's see here. H of f of 0. So let's find the first thing first. F of 0. F of 0 means I'm just substituting this. F of 0 is 5. And now I need to find h of 5. 5 squared plus 3. 5 squared is 25. 25 plus 3 is 28. There you go, our 6th example. So, what we're going to do now, you're going to start working on portfolio 1.3. Hold on to those in your binders. Remember, go back to the video if you don't understand. Remember, make sure you, before you leave, get a copy of homework number 4. This will be due the next time I see you, okay?